Hi everyone, welcome to today's webinar on Introduction to HVAC Building Tune-Ups and Commissioning. All of PGE's seminars and webinars are sponsored by Energy Trust of Oregon. We work together to make sure the concepts and recommendations you find in our training is consistent across all our individual programs and services. With that, I'd like to talk to you about the agenda we'll cover today. I'm going to be giving you my perspective on what are the benefits of basic tune-up and commissioning. And my goal today is to give you some concepts to consider, maybe give you some questions to answer. I'm definitely not going to answer everyone's questions out there as this is an introductory webinar. But the agenda will cover background, benchmarking, basic tune-ups, additional resources, and then we'll summarize everything with some next steps. Background. So this section will talk about terminology and why would you want to tune up buildings, and then we'll talk about some energy use profiles. Before I get into this section, I'd like to give you an opportunity to tell me what you're interested in. You know, what background here in this list defines best what you do for a living. And as we've done in previous seminars, you can use the tools up here at the top of the screen to mark the box that best fits your description. So we've got some sustainability managers or coordinators, we've got consultants, facilities managers, HVAC technician. Okay, I appreciate all the input, and rather than waiting for potentially everyone to chime in, okay. There will be multiple opportunities for you to provide some input and help me shape the discussion we have today. But as we can see here, we've got a wide variety of people in the audience, and I'm going to try to, like I said earlier, keep it at a relatively high level so we can talk about some of the benefits rather than getting into the weeds and of the gory details. That can be reserved for other opportunities like upcoming seminars and the like, and those will be discussed later on too. Background. So with background, I'd like to ground you in some of the terminology that we'll be using today in the webinar. And the first one is kilowatt. It's a measurement of electric power. And I know it's an archaic form of lighting, but I like to describe kilowatts in terms of incandescent light bulbs. If you have one 100-watt light bulb and you turn it on, that's going to require 100 watts of power. If you turn on 10 of those light bulbs all at once, you're going to require 10 times 100 or 1,000 watts of power, which is equivalent to 1 kilowatt. Now let's move on to kilowatt hours. That's a measurement of electricity and electrical energy, and you'll find that along with kilowatts on most of your electric bills. So a kilowatt hour, let's take those light bulbs again as the example. You have those 10 light bulbs on and you leave them on for an hour. That's 1 kilowatt consumed over a 1 hour period. That's 1 kilowatt hours of energy consumption. The next term is therms, and that's a measurement of natural gas energy. You'll see that on your natural gas bill. And we'll go into a little bit more detail as to how we translate that into other terms that we can use. The final term I wanted to bring up today is British thermal units. And basically, it's a relatively small unit of energy, specifically defined as a heating energy. It's, like I said, relatively small. It's basically the amount of heat given off by a lit match. But even though it's a small term, we can use it to help us define how buildings consume energy. If we were to convert therms to kilowatt hours and say, my building consumes an equivalent X number of kilowatt hours, that may be confusing because we need to treat different energy differently depending on what source it comes from. By using BTUs, it's a signal to anyone using that unit that, hey, I need to do some conversion of energy to make sure I'm understanding the operation of my building effectively. And like I said, I'll go into more detail into that later. So starting with background, you know, why would you want to tune up a new building? It's a new building and it was designed and should be operating right? Well, let's talk about the process. And we have a building owner who then will talk with an architect and say, hey, I need to design a 7-story office building, but hey, I want to leave some room in the bottom floor for retail space. So the architect will then have conversations with engineers and enter into contracts and start putting a design on paper to meet the building owner's demands and needs. Once the design is fully on paper, you know, the engineer in that process has determined what temperature different zones of the building need to be, how much air needs to be brought in to meet code requirements, things of that nature. After the design is on paper, contractors now work with an architect, or, you know, quite possibly they work directly with the building owner, but may have little or no interaction with the engineer. So the contractor is interpreting what is on the paper and turning it into a real life building by, you know, purchasing the steel and installing the components where they interpret where the components belong. Once the building is complete, the building owner needs to hire a building operator, and depending on the size of that building, this may be an operator whose sole function is the functionality of the building. In the case of smaller buildings, maybe that building operator also is in charge of paying bills and you know, bringing in new clients, new customers, new tenants. So they may not be able to focus on the operation of the building as much as would be ideal. Basically, we see all these lines of communication, and where there's one line, there's likely multiple conversations taking place. And whenever a conversation takes place, there's an opportunity or a possibility for a misinterpretation of what is needed. And you know, when there's a misinterpretation, there could be, you know, additional energy use being consumed. And I'll go into a little bit more detail here. So let's take the case where you've got an older building. Why would you want to tune that one up? Well, let's say the building owner has to accommodate a new tenant. Maybe the retail tenant moved out of the bottom floor and they now have a restaurant that moves in. So the building owner will work with a contractor to modify the systems that are in place, maybe add some new heating and exhaust systems. The contractor may work with an engineer who may not be familiar with the building. And then, of course, we have the building operator who's involved, and it may not be the building operator that first moved into the building. And so the building operator has to respond to the building owner's requests and ultimately respond to tenant needs, right? So if the building operator is working on complaints from tenants and customers about temperature, they have to figure out a way to satisfy the occupants. And one way to satisfy temperature complaints is to, as an example, maybe lower your chilled water temperature. And that may solve the problem. It may solve the complaint if the tenants are too cold or too warm. But maybe you can more effectively and more efficiently satisfy the customer by, you know, changing airflow rates in air handlers rather than putting a whole bunch more load on your chiller. So that's the basics of tune-up and commissioning. Am I operating my systems the way they were intended and to the best efficiency possible? So here's another chance for you to provide some input. Please check off what type of building you're most interested in. So we've got office, manufacturing, and other. So again, much like the occupations of people attending this webinar, we've got different occupancies of buildings that they're interested in. And I'm going to, again, keep things pretty generic, but we'll go into a little bit of detail here in the next few slides. Here's a pie chart of a typical energy use breakdown in a office building. And by breakdown, I mean where is energy being consumed in a typical office building. So if we look at the biggest consumers, we've got space heating, space cooling, ventilation. I'm circling those three right now because traditionally that's often referred to, that group of consumption is referred to as HVAC, or heating, ventilating, and air conditioning. So that's the bulk of the energy consumption, or the majority, the largest energy consumer in the office environment is typically HVAC loads, followed by lighting, and then we might have some computers. And then there's this category of other. Depending on the type of building you are, the type of office building you're operating, let's say there's a computer room or a server room in your building, that other may be a large amount of your energy consumption may be going to that other use. Here's a hospital, for example. Again, we've got the HVAC usual suspect, but now we've got water heating. And so maybe we want to take a look at how we're using our water heaters and our circulating pumps and minimize use there. But then, of course, we still have lighting as another major consumer. Now let's look at an industrial facility. Here's where you have to start asking yourself more and more questions because there's less and less information out there available that's specific to the way you operate your facility. We typically have some space heating going on, but if you've got a relatively small office and it's mainly a warehouse type environment, that you may not have a bunch of heating in your facility. The vast majority of your energy consumption is likely going to other pieces of equipment. This would be compressed air systems. If you're a refrigerated warehouse, it's going to be industrial refrigeration equipment. If you're manufacturing wood products, you're likely going to have some large fans for dust collection and other exhaust. So those are the types of equipment that you may need to focus your tune-up and commissioning efforts on. So here's a background or a question on background for you. Even though a new building is new, it should still be tuned up because due to the complex communications between all parties involved in its construction, there are opportunities for things to go wrong. And it looks like most of you are answering true, and so that is a true statement, and I appreciate you providing that input. Now I'll move on to some benchmarking. Benchmarking will typically involve logging energy use, comparing yourself to regional averages, and one of the tools that I use is information from Northwest Energy Efficiency Alliance and EIA, which is basically a part of the U.S. Department of Energy. But then we also can refer to Energy Star to help us with our benchmarking. So to benchmark your energy consumption, you first need to know how much energy do you use, and typically you're going to want to look at energy use over a one-year period. Any given month may have some fluctuations due to temperature and occupancy. So by looking at a full year or multiple years worth of energy consumption, you can start to see trends in your use. But who has time for this, right? You need to get a copy of your bill. You need to enter the data in a spreadsheet if you're trying to track it that way. And you repeat it once a month for years. And you can also go back in your files and look for past utility bills. So one thing that we can see on this chart is, while it may be time consuming, it can be useful. This customer used about 325,000 kilowatt hours 3 years ago. Now they're up to over 400,000 kilowatt hours. So just at a glance, you can start to see that energy consumption is increasing over time, and by tracking it, you can ask yourself some questions.
Hey, Greg. Hey, I have a question.
Sure.
Can you tell people how they could get a copy of their utility bill?
Yeah. You know, one of the best resources is someone in your finance group, right? They're the ones paying the bill. They can get you a copy. Another source is to go to your utilities website. You may be able to log in and download a whole series of billing information, a whole year, even sometimes up to 3 years worth of utility information on a monthly basis all at once. And that can be a good resource for you. Most of the time, though, you're going to need at least one copy of a utility bill to sign up to log in to that service. So basically, you need to be able to provide what is your account number and some other specific information to make sure you're getting the right information that you need. So let's say you don't have time.
Greg,
yeah.
I'm sorry, I'd like to share. One of the attendees said the customer service also has this info dating back 3 years, usually in a PDF or an Excel spreadsheet. Is that true?
Yeah, the availability of that information may be hit or miss, but that is very possible.
Thank you.
Sure. Okay, so here's a quick alternative if you don't want to or can't track down all your bills and you don't want to log in all your bills. If you get access to just one bill, you can at a glance estimate what your annual energy consumption is. And this example is for electricity energy consumption, but on most bills you'll see a graph like this, a bar chart that shows your typical or your monthly energy consumption for a series of months over the course of a full year. If we draw a line roughly at the average, we're going to see that we're at about 8,100 kilowatt hours per day. And then you do the math down at the bottom here, we're just under 3 million kilowatt hours of energy consumption in a year. And often this can get you within 2, 3, 4% of your actual energy consumption. And I'll show you how you can use that information. So now you've gotten at least one bill and you've determined what your average, even a rough average, annual energy consumption is. What do you do next? Well, you can look through some available reports that are out there. Northwest Energy Efficiency Alliance has a survey that they do periodically. This example is from 2009. I believe there's going to be a new one, if it hasn't come out already, very soon. What it does is it's a survey of different occupancy types in the Pacific Northwest, and then it has some information on location, floor area, and how the buildings are heated and cooled. Another source of information is the Energy Information Administration, which is an offshoot of the U.S. Department of Energy. And they have similar types of information through similar surveys where they look at occupancy type, how many people are in the building, floor area, facility age. So even more detail in the surveys than what we might find in NEEA. But the question is, how useful is that information for us here in PGE territory in Oregon? Well, our information in the EIA reports is typically grouped in what's called the Pacific West region, which is made up of Washington, Oregon, California, Alaska, and Hawaii. So very, very diverse climates and very diverse loads on the building equipment for heating and cooling. So there's a lot of great information out there, but you have to tweak it to make it useful for where you are located. And so here's an example of work that I've done for you to tweak it for the Pacific Northwest. Based on NEEA and IEA, we've got different occupancy types here, and the report tells us what their average KBTUs per square foot per year is. So you may recall BTUs is a British thermal unit. We're talking about thousands of BTUs per square foot per year. BTU is a small number. Therefore, we end up with some manageable numbers when we talk about thousands of BTUs per square foot per year. But now we have to put that into more useful information because we've looked at our bills. We know how much natural gas we use. We know how much kilowatt hour how much electric energy we use. If I have a building with all electric service, I can refer to this green column here, and that can give me a good feeling for how many units of energy, how many kilowatt hours I should be consuming on average if I'm one of these occupancies over here. If I consume natural gas, if I pay a natural gas bill, likely the bulk of that natural gas is going to heating systems for comfort heating and possibly water heating. So with that in mind, I've made some adjustments to the numbers. As you can see, the kilowatt hours per square foot per year has gone down because some of the energy that would have been used by, say, electric heaters is now being offset by therms of natural gas consumption. So let's take a closer look at how this might be used. I pulled off an office as an example here. So I've got the office summarized here, and let's say you're an office that consumes 120,000 kilowatt hours per year, and you know your square footage, just over 6,000 square feet. So you do the math and you come up with 19.3. The question that I have for you all is, you know, how does this compare? Is 19.3 a good result for me? And so feel free to use the marker tools to click on a box that you feel like is the appropriate answer. So we're getting some needs improvement and good and average. Yeah, I appreciate all the input, and my answer is it depends. So if I'm getting my If I do not have a natural gas bill, if I'm only getting my energy use from electricity, I would be kind of in this category. I would want to be looking at all electric service, and an average building would be 24.4 kilowatt hours per square foot per year compared to my 19.3. Hey, I'm doing pretty good. If I'm getting natural gas service, I likely want to drive that 19.3 down by saving some energy somewhere. But it still depends, because maybe, like I said earlier, maybe I have a large computer server, or even a small server room in a office building can really throw off some of these numbers. So that's a way that you can quickly benchmark your energy use and start asking yourself some questions. But with that in mind, I want to get into what if you wanted to go into a little bit more detailed benchmarking. And I'm not talking about, studying up on multiple books worth of information. I'm just saying, using roughly the same amount of information, how can we get a better feel for what our consumption is and how well we're doing? Are we efficient? Are we inefficient in our operation? So Energy Star is a good resource for you if you want a little bit more detailed benchmarking. And it's geared towards what I would call commercial occupancies, banks, courthouses, data centers, and the like. And it's geared towards those types of occupancies because it pulls a lot of the similar information from EIA, but it gives you an opportunity to further tweak things by looking at, okay, how many people do I have in my space? How many computers roughly do I have in my space? And it will help you hone in your benchmarking. It may show that your relatively high energy consumption at first blush is justifiable, or it might conversely show you that, hey, even though it looked at first blush like I was doing pretty good, I still have some opportunities to improve some things. And let's look into a little bit of detail on how that might work. If you wanted to benchmark your facility using Energy Star, you would go to energystar.gov and you mouse over this tab over here that's called Buildings and Plants. Then you can select Portfolio Manager or Target Finder. Portfolio Manager is going to be particularly useful for you if you, for example, are a property manager and you have multiple buildings that you want to track over time and see how energy efficiency projects are being implemented and how that's affecting your use and improving your use, or conversely, how move in and move out of tenants is negatively affecting your operation. Or maybe you've got a new building manager who is trying out some new things that aren't working well. This can help you see what works well for you and what adjustments need to be made. Target Finder is going to be more for if you want to just do a relatively quick but still somewhat detailed benchmark, but you don't anticipate you need to do it over a long period of time. You want to just do it once. And regardless, maybe Target Finder is where you want to start if you haven't done that already, and that'll tell you and it'll give you some information that may lead you to then think, well, maybe I should invest a little bit more time in Portfolio Manager. So what does that look like? Portfolio Manager is an online interactive energy management tool. You need to know what your annual energy use is and enter it into the tool. You can do some investment priorities. You can kind of lay out strategies for making some improvements if you identify some deficiencies. And like I said, if you're a building manager and you've got multiple buildings, this is a great tool for you to at least at a quick glance determine where you should focus your energy, on a square foot basis, what buildings are consuming more and what buildings are consuming less. Target Finder is going to be the real quick application. Again, it's an online calculator that you'll find on the website, and I'll show you a little bit more detail on how that works here in the next few slides. No login is required, so like I said, it's pretty quick. You just jot in, a dozen or so pieces of information, and it'll spit out some information for you to consider. So here's the type of information that you would need to enter into Target Finder. You want to know your location, because like I said earlier, this program is going to base your energy use and expected energy use on the weather conditions and the temperatures that you see in your region that you're operating. You want to know what type of facility you have. In this case, I've shown one building with multiple occupancies. We've got a small office, a warehouse, and a refrigerated warehouse.
Greg, I have a question on Target Finder. Can you hear me?
Yeah.
I have a question on Target Finder as compared to Energy Star. Can you input any plug load info with Energy Star?
Not typically, at least not with Target Finder. Target Finder is going to just be focusing on total meter level energy use. From that, if you want to dig into some details, you can start making some assumptions about plug load and different loads that are going to make up your total energy use, but Target Finder is not likely to be the tool of choice for that.
Thanks, Greg.
Sure. So in addition to knowing what occupancy types we have, we also need to know what square footage we have of those occupancies. We've got a building now that we've input, and we're saying that it's 160,000 square feet, and the bulk of it is refrigerated warehouse. So thinking back to those pie charts, I would be thinking, okay, I've got some heating load, I've got some cooling load, but I probably have a decent amount of, industrial refrigeration equipment that I probably want to focus on if I want to make the biggest dent in my energy consumption. Going on, we need to further define our office space. How many hours are people working in the office? How many workers are on the main shift? How many computers do we have? And if you're doing this for the first time, maybe you just want to throw in some rough guesses. You don't have to be too precise with this to get some good results out of it. How much of the office is conditioned and how much is it heated? Going on to the warehouse, again, how many workers do we have? What are the operating hours? We can see that this software is going to be reacting to the different hours, not only of a building, but the different hours that are required for different spaces within the building. And then, am I heating or cooling my space? Refrigerated warehouse is going to be an important energy user in this building, and so you tell them how many workers are on the main shift and the weekly operating hours. What you might notice here is, hey, that's not too much information that I need to put in for my refrigerated warehouse. So that kind of gives you an idea for the level of detail. This is a quick calculation, but it's going to get you in the ballpark. When you dig into the details, if you're trying to do a more detailed benchmarking, you may need to understand how different temperatures within the refrigerated warehouse are going to affect your energy use and things of that nature. And so that would be more of a detailed tune-up or commissioning process rather than this quick benchmarking. Once you put in all those pieces of information, you now get some results. So this design column is what you want to look at. This is the rating of your building. This compares your building to other buildings out there that are similar in occupancy and hours of operation and people load and whatnot. In this case, this building scored a 70. That means it's better than 70% of the other buildings out there like it. And keep in mind, this is adjusted for weather, so it's comparing us here in Oregon to Atlanta, Georgia, but it's also making adjustments for differences in humidity and temperature and whatnot. Moving on, we can see, even a good estimate of, what are my CO2 emissions associated with my project. Most of the time when you see these, you need to take them with a little bit of a grain of salt because likely Energy Star is referring to regional energy consumption and power production to come up with these CO2 equivalent emissions. Your actual CO2 equivalent is going to vary depending on the time of year. In PGE territory, there's times of the year when we're relying more on hydropower, which has, close to zero equivalent emissions, and then other times when we need to rely on fossil fuel sources that are going to bump up our emission results. But also on this page, you can start to set some targets. You know, I didn't show you in the previous page, but you can set a target level. In this case, I said, okay, if I want to be better than 80% of the buildings out there, this is the level of KBTU per year I need to be consuming, which is a bit less than my current level, which makes sense because I'm trying to be 10% better than I currently am. So that's the quick rundown. This also summarizes a lot of the information that you've already put in, and it can give you ideas for what costs you may be saving if you're able to reduce energy consumption either in therms or kilowatt hours. So while Energy Star does not have any tools necessarily for you to input information for industrial use, they do have a lot of good resources for information for you to read and respond to, and again start to ask yourself some questions and move towards making some improvements in your energy consumption based on what you see in your benchmarking. And those tools are here. We've got an Energy Star performance guide, key performance indicators. Basically, that's starting to get at, okay, if I am a wood processor, how much energy am I going to consume per board foot of process and things of that nature. And then Energy Star also has good information on compressed air equipment, motors, process heating, pumping, steam. All these technologies could be used in your facility, and if they are being used, they'll point you towards some opportunities for improvement and or focus for your capital projects or your tune-up projects. So here's a question for you. Which of the following is not a step in the process to log utility use? So again, use your marker tools to let me know what you think. Thank you very much. And yeah, so while the bulk of the answers appear to be, you know, run the Energy Star Target Finder application, which would be my preferred answer, I also see why people are saying, you know, take a look at past utility bills. You definitely, when you're taking the time to put in data, it's often best to get the most data that you can get. And so if you're going to look at a year's worth of monthly bills, and you have 2 years available, I would recommend that you plug those in too, because it's just a little bit more time, and it can give you a better picture not only of seasonal adjustments, but possibly changes that occur in your process or occupancy over time. Thank you. So now we're going to move on from benchmarking to talk about basic tune-ups, and I'll talk about level of commissioning, lighting, HVAC, and additional resources. So please take a moment to describe the building or facility that you're most interested in. Thank you. Again, there's the variety of people. So the bulk of what I'm going to be talking about is going to be focusing on, you know, the 1 to 2 story building and the 10,000 square feet or less. These are going to be topics that are not as nuanced as you're going to get with buildings that are larger or multiple floors, because the HVAC systems and the lighting controls get a bit more complicated when you get larger. That's not to say that we won't ultimately be able to address those. It's just that in the format that we have today, I'm going to focus on some of the basics. And even those basics are still going to be applicable at some level on those larger facilities too. So you can think of basic tune-up as, you know, points on a ruler. Basic tune-up on its easiest level would be performed by a customer, and there would be simple tasks, relatively low cost, that can be done to make some minor differences in your utility consumption. As you move up the scale to full-blown commissioning, now we're talking about likely bringing in a specialist, someone who's going to oversee either a design process of a new building or a retrofit process of an existing building or a total rehab of a building that we know is not functioning well. Many times, where you want to land on this ruler, is going to depend on how well you're performing. So before you decide whether you want to do some basic tune-ups or full-blown commissioning, you do want to do that benchmarking that we talked about. If you're doing average, if you're a office building that's performing average, maybe you want to start off with some basic tune-ups just to see if you can move that needle a little bit rather than putting a large investment into full-blown commissioning and not necessarily needing to make some huge changes in your operation. So here's some ideas for some basic tune-ups for lighting. Most offices today, and other occupancies for that matter, have occupancy sensors on the walls. And while these may appear to be plug and play, there are some options for you to make some adjustments, and there's just different types of sensors that may be better for your application. A lot of times in existing buildings, these sensors are going to be placed where an existing light switch is. But if you're in a conference room, for example, that light switch may be behind a door, and the occupancy sensor may not be able to do its job. It may not be able to detect motion and react appropriately by turning on or turning off lights. And so one thing to think about there is maybe a wall sensor is not for me, but maybe a ceiling mounted sensor is a good application. Down on the list is time clocks, and a lot of these may be, this type of technology that I circled here is going to be something you're going to see in an older building. And just because it's an old technology doesn't mean it won't work for you. It just means maybe you need to pay a little bit more attention to it. This time clock revolves around with a mechanic mechanism, and it has pins in it basically that determine when to turn on and turn off a piece of equipment. And this isn't just for lighting. This could be for a recirculation pump on your hot water system or something of that nature too. So whenever you have a time clock, just periodically check it, make sure the pins didn't fall out, make sure the pins are still set at the time that you want to turn on or off the piece of equipment. When we're talking about lighting, a lot of times we need to make seasonal adjustments to when we turn on and off lights. If we're trying to light a parking lot, for example, days are longer in the summer, so we need less time operating those lights. And so part of your tune-up may be making sure that you're periodically checking your timers. And then we want to replace failed photosensors and other sensors that we identify as failed. A failed photosensor is relatively easy to find because it's going to be likely controlling lights in your parking lot, and you're going to walk by a light that's on during the day when you know it should be off, and that would typically signal that a photosensor has failed, or your mechanism for turning off the lights when you don't need them is not working to your best benefit. Then the other thing to think about is sweep controls and zoning. I'm going to start with zoning. So here's an example of a floor plan for, let's call it an office building. We may have different zones. This orange zone may be an R&D function where you need a lot of light. This purple zone may be a standard office building where you need less light. So by zoning, you probably want to make the controls control these different areas in a different fashion and be able to shut off and turn on lights at different times. And many times when you have an older building that's been remodeled multiple times, lighting controls may not be the highest priority in that remodel process, and therefore your controls may not be optimized. And then sweep controls, if you have them, are a great opportunity for you to save energy as well. Periodically, controls can automatically turn off lights, say at 7 o'clock in the evening when most people go home. You can have the lights automatically turn off. And you still have the option most times to have occupants turn on individual lights, but usually they'll only turn on the lights they need at that point. And then sweep controls often give you multiple chances to sweep off the controls. So maybe you want to turn off the lights at 7, but then also turn them off again at 9 and 11 to make sure those stragglers who haven't left to go home aren't leaving lights on when they leave. Basic tune-up for lighting. You want to consider a maintenance plan. You want to clean fixtures. If you're up there changing a lamp, you might as well take a look and see if the fixture needs to be cleaned. If a clean a clean fixture is going to give off more light than a dirty fixture typically. And then group relamping. If we're talking about changing out some light fixtures that are 30 feet up in the air, if one lamp goes out, odds are its neighbors are going to go out relatively soon. And in that case, you may not want to drag out the lift or rent the lift again. You may as well change out some of those fixtures that you know are going to be going out very soon. Then you want to measure light levels. You know, like I mentioned before, you may have an office building that is converted to a warehouse. The office may need some additional lighting and the warehouse may not, but the lighting may not have been changed out. So be sure to measure those light levels.
Greg?
Yeah.
How do folks know what the requirements are for the type of work that's being done at their facility in terms of light levels?
A good resource is the IESNA, which is the Illuminating Engineering Society of North America. They have recommendations for what's typically called foot candles. It's a measure of light level, and so as an example, an office building may require 30-foot candles, but an R&D function, a QA/QC control function may require 100 watts or 100-foot candles. So by measuring the light levels, you can compare it to what it should be and then determine if you need to add or remove fixtures. And then another option for you is to change out the type of fixtures, right? If you've got some older incandescent or halogen lamps, maybe an LED fixture is a better option for you. And then when you're changing out the fixture, make sure you pick a fixture that's going to work for your needs. Be careful here, though, because most utilities, including ones in Oregon, are going to be able to offer you some incentives. And Energy Trust of Oregon offers incentives for customers of PGE and Pacific Core to change out LED light bulbs, potentially depending on the type you choose and the application you choose. And so basically that's an opportunity. Anytime you're going to be making a major investment or even a minor one, check in with your resources and see if there's some incentives out there. And I'll go into more detail in a little bit as to what some of those resources are. Now I'm going to move on to basic tune-ups for HVAC. Like I said at the opening of this section, this is going to be geared towards 1- and 2-story buildings. So we're talking about what's referred to as packaged rooftop units or split systems. These are systems that are ducted and have very rudimentary controls compared to some of the larger systems that you're going to see in a larger building. So much like lighting, in HVAC you want to implement a maintenance plan. You want to regularly check your thermostats and make sure the temperature set points make sense for your use. Keep in mind that if you raise the temperature by 1 degree, you can potentially save 1% of your cooling costs. And if you lower the temperature by 1 degree, you can often save up to 3% of your heating costs. And then also turn off your systems or set back temperatures when your rooms are unoccupied. You want to make sure you change out your filters per manufacturer's recommendations. This isn't necessarily going to save you a huge amount of energy, but it can potentially prolong the life of your equipment and help you reduce your operating budget. A dirty filter is going to move less air through the system and potentially lead to some complaints by the occupants as well. Then you want to clean equipment per manufacturer's recommendations. This is an example of what's called a condensing unit. It's located outdoors and it's part of what's referred to as a split system. This is the unit that's going to pull heat from your building when you're in air conditioning mode and spit it outside. So in order to do that process efficiently, it needs to be relatively clean. In the process of spitting the heat outside, it needs to move a lot of air through the sides of the unit. And if it's dirty, it's going to be moving less air and therefore removing less heat, causing your compressor and your cooling system to work a bit harder. But you don't want to just blast it with a pressure washer either, right? You want to make sure that you're not going to affect the operation of the unit by damaging the coils or the fins associated with the cooling equipment. So refer to your manufacturer's recommendations on that. I think this is the final question I have for you. Please check all of the following actions that should be considered when doing a basic tune-up. thank you all for that input. And as we can see, we've got answers all over the board. What I would say is all of these items are potentially good things to consider at any time. But I would like to point out that installing a variable frequency drive is what I would consider a capital project, and that's not what I would like to put in the scope of a basic tune-up. A capital project often is going to be eligible for some incentives through your incentive programs. In our case, in PGE territory, we've got Energy Trust of Oregon that will likely provide some technical assistance and or incentives to help you determine if that variable speed drive is a good opportunity for you. But everything else on this list is potentially a low-cost, no-cost thing that you can do as part of a basic tune-up. So like I said, they're all good answers, but I would not check the VFD box, the variable frequency drive box, for that answer. Here are some additional resources you can refer to. This first one is published by FEMP, which is the Federal Energy Management Program. This is the group that helps operators of federal buildings determine the best way to operate their facilities. And so it's a continuous commissioning book. It's going to give you some ideas for not only what should I do the first time I go through a tune-up, but what should I continuously be looking at to make sure I'm either staying where I want to be or improving as I want to be. The Oregon Department of Energy has some good resources too. This one I pulled off a few years back. It's from 2001, but it still has some great information. You know, most of us are dealing with buildings that are older than 2001, and even if we're not, even if we've got some newer buildings, there are some good resources in these handbooks that I'm showing you here. And then the final one that I gave you an example of here on this page is from Portland Energy Conservation, Inc. They're a group here located in Portland, Oregon. And they've got a practical guide for commissioning existing buildings. So it's going to get into, you know, different scenarios that may or may not work for you based on the type of equipment you have. There are a lot of other resources out there too. And basically, I wanted to take a chance to summarize things and talk about some next steps. So I would recommend that you benchmark your facility. Again, that involves tracking or tracking down at least one utility bill for each of your major energy bills that you have, electric, natural gas. You can even do benchmarking on water if you wanted to start that process. If your benchmarking leads you to the concept that, hey, I need to make some improvements, well, start with maybe some low-cost improvements. And we talked about some today, and if you want to learn about more, maybe attend some of our seminars that are coming up. And then also, anytime you're going to be investing money in energy efficiency, there may be an opportunity for an incentive. And a lot of times you need to pre-qualify your project before you start. And in some cases you don't need to, but you might as well check in with your resources to see if you need to pre-qualify and what are the steps to do that. If you have any questions, I encourage you to contact PGE for free assistance with incentive and program opportunities. And here are the energy efficiency resources that I've been referring to all along. PGE and Energy Trust provide free consultations by phone or on site to help identify energy savings. You can visit our website, but I encourage you also, if you're a commercial customer, to contact Paula Conway, and her information here is on the screen. And if you're an industrial customer, contact Darren Spencer, and his information is there too. If you're not with PGE, please feel free to talk to your utility in your area to see what incentives are out there for you. Thank you very much.
Thank you, Greg. And I just wanted to let everyone know that before we proceed to the question and answer portion of the webinar, I'd like to remind you that you can continue to submit questions to me through chat, and I really appreciate the folks that already have done so. And it looks like, Greg, our first question is, where can I find occupancy sensor information?
You know, a good resource is a contractor that you know and trust. The Energy Trust of Oregon has worked with local contractors to to understand how, occupancy sensors and other efficiency improvements can be incentivized through the trust. And in that process, everyone is talking to everyone about what are the benefits of different technologies. So I would start with your preferred contractor if you have one. If you don't have one, call Paula Conway or Darren Spencer, and they'll be able to give you some next steps for you to consider. And maybe you don't want to commit to anything. I mean, Paula and Darren are more than happy to talk with you, even if you're only slightly considering an efficiency upgrade.
Thanks, Greg. And our next question is, what are there LEED standards for light levels?
Oh, that is a great question. And there are standards. LEED is going to be, and I'm assuming we're talking about LEED, Leadership in Energy Efficient Design. So there are going to be some recommendations in that process that you will learn. I would definitely recommend and refer to IESNA to give you some background on light levels. And again, IESNA is the Illuminating Engineering Society of North America. Again, if you're just scratching the surface and don't need too much detail, feel free to contact the resources I've given you. The main thing that LEED is going to be looking at is an end result, right? They want to show that your building is, and they want to help you show that your building is consuming or will consume less energy than the average, and in many cases way less to get a good LEED score, right? And so LEED is a great tool to use, and it can be a good marketing tool for you as well, but maybe your resources can help you more and line up with a direction to help you determine exactly where you need to go with your lighting systems.
Great. Thanks, Greg. Next question is, when replacing HVAC units, are there incentives?
I'm going to use my favorite answer, and the answer is it depends. If you are a seasonal operation with just a few hours a year of operation, it's not typically going to be cost effective for you to change out an HVAC system. And that's a lot of what the trust is, the Energy Trust of Oregon is trying to do, is they want to help you do cost effective projects. And so if you've got a decent amount of hours of operation and a decent amount of energy being consumed, there's potential for incentives. And even beyond that, the trust is willing to work with you and offer some technical assistance. And much like the resources at PGE, they want to talk with you regardless of whether or not you have a great project or a small project or a big project. Talk to your resources, and we can give you more details. Unfortunately, that's the best answer I can give to that question at this time.
Thanks, Greg. It looks like we have time for maybe one more question. I've heard that it takes more energy to heat up a building than it does to keep it at a constant temperature 24/7. Why should I program my thermostat to raise or lower the temperature when my building is unoccupied?
I'm going to start off that answer by saying that that's what I do at my home. When we go to bed at night, I set back the thermostat, and in the summertime, well, I don't have air conditioning in the summertime, but in the wintertime, I make the house a little bit cooler. And here's why. If I were to leave my house at 70 degrees all night long, I've got 70 degrees inside compared to 20 degrees outside. There's a lot of heat that's wanting to leave my house because of that large temperature difference between those two spaces, between the inside and the outside. And by setting my temperature back even 10 degrees, I'm reducing the amount of heat that's lost overnight. Granted, I've got to make up some of that heat when I turn my system back on in the morning, but even sources like Energy Star and other well-researched outfits will tell you if you're changing your occupancy in the case of a business, and for example, if you're unoccupied for 8 hours or so at a time, it almost always makes sense for you to turn back your thermostat, set it back, and let your HVAC systems relax overnight, and then respond the next day.
Thanks, Greg. And we just have one statement here from a customer that the ETO has foot candle levels for various lighting activities or facility use activities for lighting. And that was the last question, so I want to thank you all for joining us today.